Okay, thanks for tuning into this lecture on cloud computing. This is the first of 2 lectures on cloud computing that are designed to go together. And in this lecture, what I would like to do is to talk a little bit about the context of cloud computing and a few of the trends that I think are responsible for the rise in cloud computing. First of all, I think it's important to set a definition for what I'm talking about when I say cloud computing. And it's a little vague, but what I'm going to do is present it in kind of a Mad Lib style. So as a definition, cloud computing is several, and here's 3 words you could pick between. Several infrastructures, several architectures, or maybe several visions, one of those. And what those 3 things do is they reconfigure computing from a consumer product or a capital investment into a service or a utility. So cloud computing is several visions that reconfigure computing from a capital investment into a service, for example. Kind of all of them mean more or less the same thing. And I give a couple different words to try and provide some of the scope or the boundaries of what this term means. Let's make it concrete for a second. When I talk about a capital investment, I'm talking about something like a generator. If cloud computing were electricity and it was a capital investment, you would need to buy a generator, like this generator that's sitting on the loading dock of my building. And for it to become a utility, instead of having a generator, you would have a wall socket, something that you could plug a device into to use electricity on demand. Now on the left side, a generator might make sense for an organization like a hospital or some kind of place that has mission critical things going on inside it, that if electricity were to be cut off, maybe people would die or important things would stop happening. In this case, we have a generator on this building so that servers will continue running, servers that run the institution. But when you convert a capital investment into a service, you're outsourcing the running of that generator. And you're doing it because it's cheaper to use electricity on demand, like through using an outlet, than it is to run your own generator. Now, if you had a big hospital or a big organization and you used electricity all the time and it was mission critical, it might make sense for you to run your own power plant. But for most people, in the degree to which they use electricity, it makes sense to allow an electricity company to provide that electricity for you, for them to own the infrastructure and to use it on demand through a meter outside your building, for example. This is what cloud computing is doing for computing. Rather than buying a server and running the server yourself, you use the server whenever you need it, borrowing it or using it, renting it temporarily from another organization that has larger scale and is able to provide it to many different people on a pay-as-you-go kind of scheme. Well, what's driving this change from people owning their own servers to renting servers that are in the cloud? Well, there are 5 different things that I would like to draw out: connectivity, smart devices, system virtualization, security threats, and non-transient browser applications. Let's take a look at connectivity as the first one. So it turns out that connectivity has just been growing by leaps and bounds over the last couple decades. Here is a report from Ericsson generated in November 2020, Ericsson, a mobile technology company. And you can see several different graphs here, several different lines on the graph. The red one is mobile device subscriptions for any service. So any service, voice, data, text, etc. That's at the high point there. Then we've got mobile broadband subscriptions. So this is subscriptions that have high data as part of their subscription. Mobile subscribers, so any single user. And the reason why this blue line is lower than the red line is because some users have more than one subscription. In fact, some countries, people have on average 2 or more subscriptions to each individual. Some countries, of course, usually the lower socioeconomic level countries, have less than 1 per person. The gray is a subset of the mobile devices, only the ones that are the smartphone subscriptions. We have broadband subscriptions, so these are subscriptions to broadband through an ISP at a home or some other fixed location as opposed to mobile. And then we have it broken out according to the subset of mobile subscriptions that are not for a phone device, typically mobile PC, hotspot, tablet subscriptions. And as we look at this data, we can see that there's a data collection date for when this report was written, and to the left of that is the data that's collected previously. And to the right are predictions about where the industry is going to be going. Now, a couple things to notice about this data is first is that when you count the number of fixed broadband subscriptions that you have, that's certainly going to be an undercount, because in any fixed broadband situation, it is more than likely that multiple people are using that location. Maybe a fixed access point at a coffee shop, for example, that could have hundreds of people, or a fixed location in a home that maybe has 2 or 4 or 5 users at one time. Similarly, when you count mobile subscriptions, you're probably overcounting users because users often have multiple devices for which they need to buy separate subscriptions. But the overall trend here is to notice that connectivity is going up. The scale on the left is the number of subscriptions and subscribers. It's just a raw number in the billions. And you can see that we're starting to approach, or by 2026, we'll be approaching the number of subscriptions or subscribers. Majority of the planet, a large percentage of the world population would be represented by subscriptions. Of course, they're not distributed equally, but the numbers are getting very high. At some point, this degree of connectivity changes the way that the internet operates and changes the kind of thing that happens in the world, as the dominant mechanism for using the internet becomes a mobile interaction and an on-the-go interaction that's accessible to the entire planet, to most people on the globe. That's going to enable new ways of thinking and new ways of using the internet. And we see that the trend is definitely in the upward direction, particularly for the mobile subscribers and mobile subscriptions, as opposed to the fixed landline subscriptions, fixed subscriptions in general. In terms of technology, Ericsson's done a similar analysis to see what kinds of technologies are going to be driving the mobile data boom. Again, 2020, the date at which the data was collected, approximately 7.9 billion subscriptions, and a small percentage of those were 5G subscriptions. By 2026, they predict that there will be 3.5 billion subscribers of the 5G technology. And you can see that the blue and the purple technologies are going to be diminished. They're not going to go away entirely. And the number of LTE or 4G customers is largely going to remain the same, going from 2020 out to 2026, with 5G customers cannibalizing the lower technologies, and generally all the technologies still being represented along the way. Clearly, 5G is in our future. As you look at different regions and how the technology is going to predicted to grow in different regions, we can break it down by the regions along the bottom: Africa, Middle East, North Africa, Latin America, India, Southeast Asia, Oceania, Central and Eastern Europe, Northeast Asia, Western Europe, and North America. And the way this graph is drawn is that every region has 2 bars: the current bar, 2020, and the predicted bar for 2026. The colors in the bar indicate the different technologies, which with the technologies at the darker end or at the bottom of the bar being older technologies, and orange being the 5G technology. The graph is sorted in such a way that the bars on the far right are those countries that are going to have the highest 5G adoption over the next few years. You can see that this highly correlates with wealthy countries, the countries where the investment in the infrastructure needed in order to deploy 5G is likely to be made, right? So North America is going to have a very large increase in the number of 5G subscriptions, far outpacing the number of subscriptions in sub-Saharan Africa. And this is largely just a question of spending the infrastructure and whether there's going to be a return on investment for the cellular telephone companies who are building these towers out. Western Europe, Northeast Asia, Central and Eastern Europe also seeing large increases in the amount of 5G penetration that is expected to be seen. Mobile data is going through the roof. So this is actually a graph of 2 things. It's the amount of mobile data and the amount of mobile voice traffic that is currently being used. So in this case, over on the far right is the current. There's no prediction here. The far right is the current. And the graph, the axes on the graph are the amount of exabytes that are being transmitted primarily through the mobile data mechanism. An exabyte is 1,000 petabytes. And 1,000 petabytes is 1,000 terabytes. Down way at the bottom is a little blip, which is the amount of voice traffic. And you can see that the data traffic on mobile devices is growing, looks exponential, and it's swamping any voice traffic, if that's even visible anymore. This largely being driven by video applications. Consumption of videos, YouTube, broadcast television being broadcast over the internet, and to a lesser degree, but significant, video conferencing as well. So it's just kind of interesting to think about, well, what country do you think has the fastest connectivity? Let me give you a second to think about that and commit in your head to what your answer is going to be. And then I'll show you a particular set of answers. Got it? Okay. So, as of January 2021, the fastest average median download speed was in Liechtenstein, followed by Hong Kong, Denmark, Switzerland, the Netherlands, Sweden, Iceland, etc., all the way down. See, the United States comes in at 13. You have to be a little bit skeptical about data like this, about mobile connectivity, about connectivity in general, and connectivity speed, because it's really heavily biased by how the data is being collected, when the data is being collected, and whether it's an opt-in kind of situation where people are opting in to measure their data speeds, or whether it's being done through the infrastructure. But nevertheless, although Liechtenstein has the bragging rights here, what I really want to draw your attention to is that the countries that are at the top tend to have small geographic area and tend to be very wealthy. So the way that you get high connectivity speeds is to be wealthy and small, because it's easier to build out infrastructure for higher speed connections if you don't have a large geographic area that you have to attend to. It's much more difficult for China to bring 5G technology into its country than it is for, say, Sweden to bring 5G into their country, just because of the sheer amount of land area that needs to be covered by the towers in the case of 5G. It's obviously not equally distributed across the United States. So here's another graph, slightly different collection of data, showing the average median download speed colored and shown in a map form. And you can see that Northern European countries have very high download speeds. And you can also see that Japan and South Korea have very high download speeds. Some little bits of green sprinkled around in there for those small countries. And then you can see that when a country becomes large, it's hard to break into those green colors. If you want to be yellow and you are a large country, you also have to have some degree of wealth that you can leverage in order to build that out. So connectivity is driving the change to cloud computing. Smart devices are also driving some of this change. So I just showed you this graph of mobile data growth. Well, part of it is because of the increase in consumption of data, but the other thing is because of the increase in the number of mobile devices that are present, and being purchased and being deployed. So two factors, the amount being consumed and the number of devices is just growing enormously. If we break it down according to different countries, you can see a similar kind of trend where the growth in mobile data traffic per smartphone is increasing based largely on the wealth of a country. So North America projected to see the largest growth in mobile data traffic, followed by Western Europe, and then Northeast Asia, and then India is the top four. You can see that this graph is predictive. It's kind of in the middle left, we've got the current state, and you can notice that currently right now, Northeast Asia has the most mobile data traffic, but that's expected to be overtaken by 3 other regions in the next few years. Don't forget about Internet of Things devices. So those devices that aren't smartphones, that don't really interact with people on a moment-by-moment basis, or don't require interaction with the person in order to operate. There's a whole range of kind of sensor-driven devices, appliances, all kinds of Internet of Things devices that are also coming online, driving some of that data traffic, also driving a number of places in which you can collect information about the world or interact with the world as well. So we've got connectivity and smart devices. What's the third trend driving this change? Well, I would say it's system virtualization. This is a very different kind of trend. Let's imagine that you have a computer. This is the clip art represents that computer. There's some software that you can run that's called a virtual machine, and I'm going to show you an example of that, Oracle Virtual Machine VirtualBox software. And what this software does is it runs on one computer. We'll call that the bare metal computer, or sometimes the host computer. And what VirtualBox will do will run several simulated computers on top of that computer. So here's what the interface to VirtualBox looks like. Oops, sorry, I jumped too far. We've got several computers down the left side. These are all computers that are running independent instances. You can see snapshots in the red, and then you've got a Windows 10 machine there. Each one of these computers is being simulated. The operating system that's running inside them doesn't realize that it's not running on an actual metal computer. It thinks it's in its own environment on its own computer, like any other computer in the world. This particular software allows you to run several of them. So here we see that there are 7 computers that are all running on the bare metal. I have this installed on my computer, and let me show you just a run through of what it looks like to run a virtual machine on your computer. Why do I do this? Well, I do this because I run on a Mac computer, but sometimes I need a Windows computer to run software that's only available on Windows. And so in order to do that, I host a virtual machine on my Mac that runs Windows 10. When you start it, you get the control panel, you hit start, it brings up a window, and it looks like the desktop of a Windows machine. In fact, it is the desktop of a Windows machine as far as the software knows, but you can see that it's running embedded in a window on my Mac. I'm going to let this run and speed it up so that we don't wait for the software to load, but I just want you to see what it looks like to run one of these guest operating systems on top of your host operating system. The VirtualBox software is free, and so you can download it and try this out as long as you have a license to run the operating system that you want to put on the guest computer. So then, when it's completely shut down, the hard drive, the virtual hard drive, exists as a file on my Mac computer. When I start it up again, whatever work that I saved while I was in that session of Windows 10 will still be there, saved in a file on my Macintosh hard drive instead of on an actual raw hard drive. It's a simulated hard drive, simulated in a file. System virtualization can be done through a variety of different packages. There are more than what I've just listed here, but just to give you some names, there are commercial products that do system virtualization. So VMware and Parallels are two companies that do commercial versions of the software. You can get open source versions of virtual machines. The Zen project is a famous one. It's open source and free. And VirtualBox, which is run by Oracle, is available for download. You're able to, as I demonstrated, able to use virtual computers as well. A much more recent technology is Docker. Docker is slightly different than system virtual machines. They call their software containers. And what's different about a virtual machine and a container is that a container is much lighter weight. A container doesn't run a separate operating system in each image. Each host container doesn't run a different operating system. It runs the same operating system as the host machine, and because of that, it's able to get much higher efficiency and much higher speed than if you're running a separate operating system in each virtual machine. It's good for different kinds of workloads. Sometimes you'd like to run a bunch of virtual machines where you maybe are running Android or a legacy Windows version that you have software that has to be in a legacy version. Or maybe you're testing out a different piece of software and you'd like to do it in a virtual machine. You can do that with a traditional virtual machine software. In a Docker container, you're typically running a Linux virtual machine on top of a Linux host computer. Well, virtualization powers most of the large data centers and the data center companies. So like Amazon, Rackspace Linode. This is a picture of a Rackspace data center. Pretty boring building just filled with computers and air conditioners and power lines that are running a lot of virtual machine software that are being rented out to consumers, all over the world. This is being enabled by a lot of new chips. For example, this chip from Intel that has 72 cores on it. what the heck is a consumer going to do with 72 cores? Even a really demanding workload of editing a movie and doing Photoshop and checking email, and I don't know what else you're going to do on your computer that needs its own processor. But these modern Intel processors have an enormous number of cores. What can you do with them? Well, you could run 72 different virtual machines on them, for example. Netflix is rumored to launch millions of containers per day in order to attend to the demand on video streaming services and website interaction that is generated by their customers every day. So a very heavy consumer of containers that are very lightweight, easy to start, easy to deploy, easy to move around. So the benefits of system virtualization is that you get really high efficiency. You can fully utilize these bare metal host hardware that have 72, 64 cores on them. And when you are able to use system virtualization, well, suddenly 72 cores seems reasonable. I'm going to let 72 of my friends run their applications on top of my computer. Portability. So it turns out that because a virtual machine or a container is just a software file that's sitting on your computer, it's really easy to move them around. Move them from one computer to another computer, move them from one data center to another data center. Maybe in order to even out the load in your data center, you want to move the virtual machines to different particular host hardware, or maybe to even out the load in a data center. Or maybe you want to move your load from one data center to another data center based on the price of electricity or the price of air conditioning. And maybe you even want to do this without telling anyone. Someone who's using a virtual machine doesn't actually necessarily know where exactly their virtual machine is. And as long as you as a host provider can maintain connectivity to the user, you can move it around however you'd like. You just have to make sure that the system continues to be available while that's happening. Another benefit of system virtualization and of containers is isolation. If you're doing some kind of particularly sensitive work that needs to make sure that two computers aren't interacting with each other, well, virtual machines and containers provide additional security to allow that to happen. Maybe you are doing, you're testing out a development software, or maybe you're doing something that is has company secrets associated with it. You don't want any malware to leak that stuff out. You could put it in a separate virtual machine. Of course, it enables you to run multiple operating systems at the same time if you're using a traditional virtual machine, so you can test out software on different platforms. And it also supports disposable computing. What's disposable computing? Well, let's say that you have a conference that you're running and you're just going to need a computer for a couple months in order to run the conference website, give people directions, and maybe run a registration system. Well, with disposable computing, you can ask one of these service providers to give you a virtual machine that they keep running for just 2 months maybe. And then when you're done, you just shut it down. And the host provider deletes the file. And the only thing that was spent was electricity along the way. You didn't have to buy a computer. You didn't have to physically house it anywhere. You just had a temporary computer and disposed of it. All right, a fourth thing that's driving this change is security threats. So let's use a metaphor of baseball. Whoa. How about that for green screen? In the security threat arena, we've got professionals. These are organizations like nation states trying to break into your computer. They have access to the smartest personnel, the best and brightest of their country, and possibly the people who are running the companies that are making the software and making the hardware that they're trying to break into. They have effectively unlimited resources. They can spend an enormous amount of money trying to break into a computer. Typically, they're motivated by political or military goals, trying to destroy systems or take down systems or steal secrets. The next level down, we've got the semi-pros. Semi-pros have different motivation. These are organizations kind of like organized crime. They're motivated maybe by money or by ideology. These are the kinds of organizations that try and break into your computer and run ransomware to encrypt your hard drive. And after you pay them a certain amount of money, likely in Bitcoin, they may or may not give you the password to decrypt your machine. Finally, you've got the amateurs. And when I say amateurs, I don't mean they don't know what they're doing. I mean they're not part of an organization that is directing their efforts. These kinds of players are motivated by bragging rights, proving that they have the skills they claim they do to break into computers. Or maybe activism, kind of a vigilante justice. They perceive some wrong in the world and they go about trying to address it by breaking into a computer and making a political statement or breaking the system of the perpetrators that they have identified. Who are the professionals? Well, it's organizations like China, the US, Israel, Russia, all organizations that have various times broken into other countries' computer systems. The semi-pros are organizations like Al-Qaeda or North Korea. Not quite as many resources as a typical nation state, motivated by ideology, many times by money as well. And then the amateurs are organizations like Anonymous or LulzSec. Again, not organizations that don't know what they're doing, but organizations that are not driven, that don't have an organizational chain of command, much more like networked organizations. All right, the final thing I want to address as to what's driving cloud computing is non-transient browser applications. What do I mean by that? Well, non-transient browser application is a program that you spend significant time with, but exists in a browser. So this is largely enabled by modern browsers that have offline storage, WebSockets. WebSockets enable real-time push updates without having to refresh or reload your website. Real-time collaboration, so you can see what your collaborators are doing on your website. For example, what happens in Google Docs if you're writing with someone else. And very fast client-side JavaScript so that your browser can run code very quickly. So a transient browser app would be something like shopping at Amazon. Something which you do, okay, maybe it's going to take 20 minutes, but if there's a little bit of lag or the user interface isn't ideal, it's going to be okay because you don't spend a lot of time there. But there are other applications that people increasingly are spending hours and hours and hours in, but that are located in the browser app, right? In the browser itself, not in a native application. That's a non-transient browser application, something that people are spending lots of time doing work in. Examples of this are things like Gmail, Google Docs, maybe online photo editing. Probably everyone's familiar with Gmail, and as much as you like to think of this as a transient browser application, you can spend, I can spend 8 hours a day doing email all the time if I didn't have class to teach and other things that demanded I break away. As much as we wish Gmail was transient, it's a pretty non-transient browser application. Likewise, Google Docs. Used to be a native application, Excel, Microsoft Office, still in heavy use, but in competition with our cloud-based spreadsheets and cloud-based word processors like those in the Google Workplace suite. Finally, there are different kinds of applications like this online version of Photoshop style software. Applications that you traditionally wouldn't expect to be able to be housed in a browser, but now can be because of the power of those browsers. So, the world has changed. As far as connectivity goes, I now have the ability to reach any computer in the world at high speed and wirelessly. And when I do that, I have a portable device that has a really high quality interface and it can reach any other computer in the world through this connectivity. I have system virtualization. So actually it's now really cheap to run powerful computers in consolidated data centers because those 72 core machines can give me disposable and fast and low cost computers. Well, on top of that, I may not be interested in running my own server because it requires professionals to keep computers and data secure when you are the target of sophisticated enemies. And finally, I don't actually need to be able to run a program natively. I'd rather run the latest program released every day because when you open up a browser and you go to Gmail, you download the JavaScript and the interface fresh every time, almost every time. And that enables Gmail to be able to do new releases of software on a 2-week schedule. And that's a lot better than typically you'll get with a native application. All these things together are driving us to use cloud computing. We don't need the native computers, native applications. We don't need high power local computers. And in fact, having them is a security risk on top of everything else. So now the economics have changed. The first wave of computing, maybe, if you use the ubiquitous computing framework, it was cheaper to share a mainframe because mainframes were very expensive and we're all going to go to that mainframe in order to use it. In the second wave, it's cheaper to have your own desktop. Desktops, IBM PC, early Macintosh situation. In the third wave, it's now cheaper to rent computation from the cloud because of the changes to the landscape that I've described. And in some ways, this looks a little bit like going back to the first wave because now we're going back to a data center, although the data center looks really radically different than it did in the first wave. So key points. Cloud computing treats computing as a service. You pay as you go, rather than investing in some kind of capital investment or some consumer product like a big honking server that's going to do all your work for you. And the world has changed so that this makes a lot more sense. Technological factors like connectivity, device access, virtualization, social factors like the security threats and the change in workflow and workplace demands, and then finally economic factors. It makes sense economically to do this as well. So thank you for your attention. Hope this puts a little structure around the world of cloud computing, gives you a little bit of a definition of how to talk about it, and helps you to be able to correctly analyze the trends that you see taking over our global internet world. There's an outlet for you.